Okay, I've made similar questions to what you have in your project. Change the details though, so I'm not giving away the right answers. Okay. So, premise one: you take the medicine A, you do not get illness B. Okay. P could be taking the medicine. Q could be getting the illness. Then this is P, right arrow, not Q, is what that says. Let me see if I drew that. Yeah. Oh wait, no, we need the not symbol. There it is. Okay. If we let P be the event that we take the medicine, Q is the event that we get the illness, then premise one is P implies not Q, like I've written here. And premise two says you didn't take the medicine, that means not P. And then the argument is that you got illness, you got that illness. I didn't get very inventive with the names, did I? So the argument is that if you didn't take the medicine, then you definitely got the illness. But that's not true, right? You can not take a medicine and still not get an illness. There's other ways you could avoid an illness. You might never come in contact with it. Some illnesses happen just by chance. So is it a valid argument? Without using a truth table, we'd say no. Okay? If you use a truth table, remember what happens. Let me see if I can get it back. I can't. Remember what happens if this first part of the statement is false. You mark this whole thing as true, right? So if this part is false, which is what the premise 2 is saying, then this whole condition should be true. That if you take the medicine, then you'll not get the illness B. It doesn't say anything about what happens when you don't take the medicine, is what I'm getting at. Okay. So here, I can help construct that truth table too. Okay, so if we need to make a truth table, we have two events, so we'll do P and Q, true, true, false, false. And then Q, we're going to go true, false, true, false. We alternate to consider all the possible options. And then P implies not Q, the negation of Q. We want to remember the negation of Q, not Q. So if P is true, then not Q must also be true, but not Q is false on this row. So true implies false, false. Okay, true implies true for this one, because remember, we're considering the negation of Q. I guess you could do another column with the negation of Q if you have trouble with that. That's true. And remember, if the first part of the statement is false, it gets marked as true in the table. Okay. The truth table says that if P is false, then we can't make a conclusion about what happens if, the truth table doesn't tell us anything about P being false is the big idea. Okay. We only have a condition for when P is true, and then we can start making some statements. So this truth table is great if you tell us that you took the medicine, but the truth table doesn't help us in this case because it doesn't have anything to say about the negation of P when P is false. Okay, when my premise 1 and 2 are true, so premise 1 is not P, so here we'll make one last column, negation of P. This is false, false, true, true. So what happens when premise 1 and 2 are true? Premise 1 was this third column. Premise 2 is this fourth column. So when premise 1, which is our third column, and premise 2 are true, that's the third and the fourth row. It tells us there's two options. That Q could be true and Q could be false. So it means we can't make a definitive statement. It could be true that you get the medicine. It could be false that it could be true that you get the disease. And it could be false that you get the disease. So that last part, what does the truth table say about the argument in premise 1 and 2 are true? It doesn't tell us anything about Q. Q could be either true or false, so it doesn't make a determination. So the argument is invalid. You got illness B, that's possible. That would be this outcome. But there's another outcome when premise 1 and 2 are true. This row right here. Okay, I think I have something that matches the second one in your project. If the documents have been falsified, then the defendant is guilty. So I'm going to do it just like the last one. P is that the documents have been falsified, and Q is that the defendant is guilty. So we can make a truth table, just like we did before. P, Q. So this is true, true, false, false. True, and then we want to alternate. False, true, false. And then we got, let's see, premise 1, the documents have been falsified, then the defendant is guilty. So that means documents have been falsified, that's event P. Then the defendant is guilty. That would be Q, the way I've defined it. Because Q stands for the defendant being guilty. And then, so true implies true, that makes true. True implies false, that's false, according to what we did in Newton. And then if the first part of the statement is false, it doesn't matter what the second part is, we mark it as true. And then premise 2, the documents have not been falsified. So that means we're doing not P again. And that's false, false, true, true. So what are the, and then they said the defendant is innocent. That would mean not Q, right? The argument is that the defendant is innocent. So Q would be false in their situation. So what you want to do is just like on the last one, look at premise 1 and premise 2. Find out when those two premises are true. Premise 1 is true in the first, third, and fourth rows. Premise 2 is true in the third and fourth rows again. So these are the two places that are true for both of those premises. What does that say about the possibilities for the defendant? Look, again, the defendant could be, it could be true the defendant is guilty, or they could be innocent. Could be either one. Our truth table does not give us enough information that was make a statement. We can't say whether this person is innocent or guilty. Okay. All right, so my part 2 is similar, except it's talking about car accidents. F is that the client had a car accident where car insurance is going to have to pay. Okay, so F means they've had one accident, had a qualifying accident, so one accident. G is that they had one or more qualifying accidents. So there's some overlap here, right? A person could meet it could be event F, they had one accident, and they can be event G because G represents one or more accidents. So which of the following events are the same as F? So this is actually the second time making this video because I made a mistake earlier today when I made it, and a classmate correctly pointed it out. Okay, so F is the event that you have an accident in year 1. And it's a qualifying accident, so exactly one accident. You don't have 2 in year 1. You don't have 3 accidents in the first year, just one accident. And G is the event that you have 1 or more accidents in year 2. And we're supposed to identify F and G, both of those events happening together, okay? So that means we had 1 accident in year 1, and we had at least 1 accident in year 2. That's what F and G means. So option 1, the customer had exactly 1 car accident in year 1. That's good. That's F. And has more than 1 car accident in year 2. That's close but not correct because it says more than 1. G says you could have 1 or more. So it's excluding the option of having just 1 accident in year 2. 2, the customer had exactly 2 car accidents during the 2-year period. Now, I actually marked this correct the first time, but that's not right because it's close. You know, you will, if you have F and G, you will have 2 accidents during the 2-year period, but 2 isn't specific enough. 2 should be saying that we had 1 accident in year 1 specifically. It's not clarifying. The 2 accidents could have happened in year 2, so this doesn't fully explain F and G. 3, the customer has exactly 1 car accident in year 1 and has at least 1 car accident in year 2. So having exactly 1 car accident in year 1 is correct. That's event F. And has at least 1 car accident in year 2. That's event G. That's exactly what those 2 events are. So this one is correct. 4, the customer has exactly 1 car accident in year 1. That's fine. That's F. And that's good because that's the intersection operator. Has a total of 2 or more car accidents in the 2-year period. So this one's also correct because it's in the 2-year period. At first I thought it was saying in year 2, but that says 2-year period. So if you have one car accident in year 1, and then if event G is true, that you have one or more accidents, then you have at least 2 accidents, because at a minimum, you could have 1 accident in G. So one in the first year, 1 in the second year. That is 2 accidents in the 2-year period. So that's correct. The customer has exactly 1 car accident in year 1 and has more car accident in year 2 than in year 1. That's possible, but that's not guaranteed, because you could have an equal amount. You could have 1 accident in year 2. So this one is also incorrect. Okay, but these parts were right in the previous video. And what in words, what would event G complement be? That's the opposite of G, right? So if G is that you have 1 or more accidents in year 2, G complement would be having no accidents in year 2. Then what would F or G be? I'll let you do that one. This is saying event F, that you have 1 accident in year 1, and this would be specifically using the word or, okay, that you have 1 or more accidents in year 2. But when we're talking about this operator, this is the union operator, and that we need to say the word or, because it could be just F, or it could be just G, or it could be both. Okay, this last one's the same. I've just changed the numbers. So what you want to do with Venn diagrams is what we talked about in the discussion board, okay, with those example posts I made. So here's Venn diagram 1. I think there's 3 different types of houses. Here's Venn diagram 2, and here's Venn diagram 3. You want to start with the innermost portion, because you might be double counting houses, not horses, if you don't. So right here, 3 policies that ensure, there's 3 policies that ensure 3-bedroom. We'll make this the 3-bedroom circle. The 1 story, we'll make this one 1 story, and 2 baths homes, we'll make this one here. So it's saying it meets all 3 of those criteria, so 3 goes in the center here, okay? Part 6, 20 policies ensure 3-bedroom, 1-story homes. So 3-bedroom, 1-story homes, where do those intersect? It's right here. There's 20 policies that meet that criteria, but we've already accounted for 3 of them over here, so there's 17 policies that go here. Done with that one. 35 policies that are 1 story, 2 baths, so we're talking about this intersection here. So you've already accounted for the intersection between these 2. You've already got 3 accounted for here, so that means there's 32 left here. And then the last one, 3-bedroom, 2-bath homes, that's this portion right here. We've already got 3 people down here, so that means there's 7 left over up here. And there's 170 policies that ensure 2-bath homes. This is our 2-bath home circle over here, right? We've already got some of those 170 listed here, so we got to take 170 and subtract out 170, subtract out the 7, the 3, and the 32 that are already in the Venn diagram. So there's 128 that are not 3-bedroom and 1-story homes that don't meet the other criteria. And so 230 1-story homes, so we've already got a few in that circle listed, so you got to subtract those. 230 subtracted by 32, subtracted by 3, subtracted by... There's 178 homes that fit this criteria. And you probably know what to do for the last one. You take 100, subtract the 17, subtract the 3, subtract the 7. So there's 73 homes up here. Now remember, they say that there's 1,000 homes total, right? So let's see how many we have in our Venn diagram. Add up all the numbers in the Venn diagram. Okay, if I added those right, I've got 438 in my Venn diagram. So that means there's an additional 562 homes that have none of these 3 criteria. So there's 562 homes that are not 1 story, that do not have 2 baths, and they do not have 3 bedrooms. Okay, that's what they're asking for in this problem. How many homes do not meet any of these criteria?